Let's take a look at the first derivative test and how it can tell us where a function is increasing and where it is decreasing. So we're given a function, here it is, and we're asked for where it's increasing, decreasing. There's a frame that we use for these problems. The steps and conclusions we follow every single time, and so you always want to set up your frame. We're going to find the first derivative first. It is the first derivative test. And so the first derivative of our function x cubed gives us 3x squared. Minus 7 over 2x squared gives us minus 7x. Minus 6x gives us minus 6. Derivative of 20 is 0. So that's our first derivative. The next thing we do is set up that derivative equal to 0, or figure out where it's undefined. Now this function, because it is a polynomial, is defined for all x, and so we don't have any that are undefined. So that's not going to apply here. We are going to take this function, that derivative, set it equal to 0, and then we have to solve it. So now you need your quadratic equation solving skills. We're going to go ahead and factor, and the only two factors of 3 are 1 and 3, so those are a given. We need two factors that multiply together to be 6. That's 1 and 5, or 2 and 3. I'm going to use 2 and 3. And let's go ahead and check. 3x squared minus 9x minus 2. Oh, I need a change in my sign. This guy needs to be positive. And so 3x squared minus 9x plus 2x is minus 7x, and then minus 6. Now we use the 0 property to set each of those factors equal to 0 and solve. Subtract 2 from both sides, divide by 3. One of the x's is negative 2/3. Then x minus 3 equal to 0. You get x equals 3. Our critical values are negative 2/3 and 3. Those go on the number line. So you come down here, negative 2/3, and put your positive 3 on there. Now that you've got those on there, I'm going to move this up. Now, both of those are dividing places because that's where the derivative is equal to 0. And so let's figure out what happens on either side. Name this as f prime of x. We're going to do some test values. Let's test a value here, in between, and here. The test values are saying, and what we know with increasing and decreasing, is that our functions only change increasing and decreasing at critical values. And so we know that everybody within each of these intervals is going to have the same positive or negative increasing or decreasing characteristic. So we take f prime of negative 1, substitute it into your function. When you do that, you find a positive number. F prime of 0, substitute the 0 into the derivative, you get a negative number. Substitute the 4 into the first derivative, and you get a positive number. So what this is saying is that this function is increasing here, decreasing here, and increasing here. That's what the first derivative test gives us. And this is the sign chart we need to show our work. And let's go ahead and give our conclusion. And our conclusion is that, remember, it was asking us where it's increasing and decreasing. It's increasing on and decreasing on. And let's work left to right again. That first interval, this is negative infinity over here. From negative infinity all the way to that critical value, negative 2/3, it's increasing. Then it's decreasing from negative 2/3 to 3. Then it goes back to increasing again. So you put the U for the set notation to bring these two sets together. 3 all the way up to positive infinity. And then you are done. So the first derivative test is saying that I'm going to test the first derivative to find out whether my function is increasing or decreasing at any given value. The critical values that we found up here are key to that whole piece. So this is the frame you want to use. Now, where that leads is that we get to name relative maximums and relative minimums. So if you have an interval on which everybody in there is bigger than the y values for all the rest of those x's, then we have a maximum. and we call it a relative maximum. And it's relative because the function could go to infinity in the far left or far right. So we're only talking about in the neighborhood. And then if that value is less than x for all of that interval, then here you have a relative minimum. So what this gives us up above, and what we could use, is that because this guy is going up and then down, here we have a relative max. Here, because f of c, this guy's value, is less than everybody else around him, he's a relative minimum. So we get to name them. So this first derivative test allows us to find increasing and decreasing, but it also then leads to this idea of being able to name relative extrema. Here are the steps that we used. Don't forget your sign chart. Remember, the work you show to prove what you're doing is just as important as this final answer. That's it. Hope you're having a great day.